Hello, dear students. In this video, we are going to see how to convert a regular expression to DFA. What is the purpose of regular expression? Regular expression is to write a pattern. So, what to be matched? If you know, in compiler, the first phase of the compiler is lexical analyzer. In the lexical analyzer, we want to do the tokenization, in which we want to match the patterns, which means we find all the patterns, that is the lexeme, and then we will be converting it into tokens. Either it can be an identifier token or a keyword token or an operator like that. So here is the purpose of regular expression. So it helps us to identify the patterns. Is the pattern is an identifier? Is it the pattern a keyword? Is a pattern is a operator or something like that? So, for example, let me give an example. If I want to identify the identifiers, so how will we write the regular expression? So always, the identifier will start with letter, followed by letter or digit, and zero or more number of times. This is an example for regular expression to identify the identifiers. Identifiers means what? The name which we give for a variable name or a function name. So this is one example for regular expression. This regular expression need to be converted to DFA. What is DFA? Deterministic Finite Automata. So DFA will be easy for a machine to execute it efficiently. So only we are going to convert the regular expression to DFA, which means in DFA, when we have a state called A, when we give A as an input, it will be going to only one another state. For example, B. For the same input A, it will not go to more than one state. So that is why we call it as deterministic finite automata. Finite automata is a mathematical model to represent a pattern. So here it is so deterministic that it is determined where to go for a particular input. So it is easy for a machine to understand it and execute it efficiently. So that's the reason why we are going to convert a regular expression to DFA. So in this process, we have some steps. The first step is construct a syntax tree. And in the regular expression, you have to append a hash. For example, if you consider this is a regular expression, at the end of the regular expression, you have to append a hash. So, for example, like this, append a hash. So, what is the use of it? It will say the end of your pattern. So, to denote that, we have to append a hash. And then we have to find some functions. Before finding some functions, we have to convert this regular expression to a parse tree. The parse tree is also called as syntax tree. So from the syntax tree, we have to find some functions like nullable, and then we have to find the first position. We call it as first pose. And we want to find the last position, and also we want to find the follow position. So these are the functions we want to find from the syntax tree. After the syntax tree, then we do the detransition. So then detransition means deterministic the transition. So that will help us to find this DFA and also the transition diagram. So these are all the things we are going to do here. Okay. So when you construct the syntax tree, these are the three different kinds of nodes we will be finding. One can be a star node or concatenation node or a OR node. Let's see the rules to find the first nullable, first position, and last position. So, if a leaf node, so first from the regular expression, we are going to find the syntax tree, right? So, in the from the syntax tree only, we are going to find all these three functions, that is nullable, first position, and the last position. So, when we have syntax tree means we have internal nodes, leaf nodes, all these things. So if a leaf node, for example, if a leaf node is epsilon, that is empty, then we have to find the three functions. Then the nullable is true because it's empty. And what is the first position? First position is null. What is its last position? Last position is also null. That's what represent in this first row. Okay. And then Next, let us go to the next second row. So what the second row says, if the leaf label with the position I, you consider there is a leaf no. Okay, I'm going to label it A. And I'm going to give a position value that is 1. This is the I value. Okay, this position value is denoted here as I. So in this case, if a leaf node, this is a leaf node. Okay, you consider this is a leaf node. And if the leaf node has a position value I, that is here it is 1, then what is its nullable? For this, the nullable is false because it is not null. And then what is its first position? First position is the I value itself. That is here it is 1. What is its last position? The I value itself. That is 1. So let us write here as first position is 1 and the last position is also 1. So that is what denoted in the second row. And let us go to the next one. Third row. What is third row specifies? If a syntax tree have a part like this, what does it mean? There is an R node with 2 childs. Okay, 2 child. Let us say it is A leaf node and it's a B leaf node. This is child C1 and this is child C2. And it also have a position number. Let me give the position number as 1 and 2. So let me say the position number as this is 1 and this is 2. So if this is the case, also again we have to find these 3 functions, nullable, first position, last position. So what does it say? For nullable, what is a nullable? If nullable of C1 or nullable of C2, we know already for a leaf node, and what if with a position I, the nullable is false. That's what we saw I discussed in the second row. And for this also we have position, so nullable is false. And for this node is called as R node. Okay, so for this R node, if the nullable value is false, so for this node, we already know the position is 1 and the last position is 1 here. Here the first position is 2 and the last position is 2 according to the row number 2. Because a leaf node with the position I, that position itself become the first position and the last position. Now we have to do for this R node. So what is the nullable of this R node is, if both the child is nullable is false, so the truth table you know, right? False or false is false. True or false is true. False or true is true. And true or true is true. So that's what here nullable is. So given here, nullable of C1 or nullable of C2. So this is C1 and this is C2. So the nullable here in this case is false or false is what? False. So for this false. And now, what is the first position of an R node? First position of C1 union, first position of C2. That is child 1's first position, union child 2's first position. So here child 1's first position is 1, child 2's first position is 2. So the union of these two. So the R node's first position is 1, 2. What is its last position? Last position of child 1 union, last position of child 2. So here again, the last position here is 1 for child 1 and last position of child 2 is 1, 2. So this is the first position, this is the last position, and this is the nullable. Okay, hope you got it. And similarly, let us go to the next node. If the next node, if it is an AND node, so this one, okay, this one. If the node is an AND node, and we can also call it as concatenation node. So that's what we have saw here, right? Concatenation node. It also has 2 childs, let's say A and another one is B. So this is child C1 and this is child C2. This is a leaf node. So it always has the same rule which we saw in the row number 2. So its nullable value is false. Here also nullable value is false. Look at the second row so you understand. Since it has some position, the nullable value is false. And what is first position? The I value itself. That's what we discussed already. So here also it is 2 and here also it is 2, the I position value itself. Now we have to know what is the nullable value, first position, last position for this concatenation node. So what is given in the rule is, what is the nullable? The truth table of AND. So what it is? True and True is only true. All the others are false. We know that if it is true and false is false, false and true is also false, false and false is also false. So in this case, only both true means only it is true. So here in this case, if you see, it is given nullable of C1 and nullable of C2. So here the child 1 is nullable is also false, child 2 is nullable is also false. So here the nullable is false. And what is its first position? If the child C1, this is child, right? If the child C1 is nullable is false means take the first position of child 1 alone. And if the child 2 is nullable is also false, then take the last position of child 2. That is what given in the else part. Or else, if the child is nullable is true, then what you have to take? Take the first position of C1 union first position of C2. So it will become 1, 2. Same way, in the last position, if the child 2's nullable is true, then what you have to do is last position of C1 union, last position of C2. So again, to become 1, 2. If the nullable value is true. So that's what mentioned here. So if the nullable of C1 is true, similar to this, first position of C1 union, first position of C2. Similarly, if the child, for the last position always take the second child. First position take the first child. So for the last question, check child 2. If the child 2's nullable is true means take the union of last portion of child 1 and last portion of child 2. That is 1, 2. If the nullable is false means take the last position of child 2. So for last position, take last position of child 2 if the nullable is false. For the first position, take the first position of child 1 for if the nullable is false. If the nullable is true means take the union of first position of child 1 and first position of child 2. Here, if same way, if the nullable is true here also, take the last position of child 1 and the last position of child 2 union. Right? This is what's specified in this rule. And let us go to the last rule. The last rule is about if your node is a star node, always remember star node have only one child. And so if it is a leaf node, definitely it has a position. So that position itself is its first position and last position. No change in that. What is its nullable value? It is false. Okay, for the leaf node, this nullable is false. Now we have to find for the star node according to this row, the last row. So what is its nullable? Nullable of star node is always true. What is its first portion? First portion of child 1. What is its last portion? Last portion. So same thing will be coming to the first portion and last portion. So this is what explained here. So for star node, nullable is true. First portion is first portion of child 1. That is this one. And the last portion is last portion of child 1. So that same thing will be coming for here. Hope you got it. Okay, then next let us go to, so this is how we find the nullable first portion and last portion. Now let us go to the rule how to find the follow position. How to find the follow position. So follow position can be found for only two nodes. One is for the star node, another for the concatenation node. So star node and concatenation node only have the follow position. So let's discuss about the rule of it. Let's consider there is a star node. As I already told, star node have only one child. Okay, and assume it has a first position as A, B and the last position as C, D. Okay, so in this case, how to find the follow position? That is what we are going to find. So if this is the case for, this is how it will be looking like, right? C, D. So how will you find the follow position of a star node? Is see every position, okay, in the last position of star node will have all the position in the first position of the star node. Similarly, so every position, what is the meaning? C will be having all position in the first position of star node. Similarly, D will be having all the position from first position of star node. So A, B. Right? So what is the definition? Every position in the last position of star node have all position in the first position of the star node. So C will be having A comma B, D will also be having A comma B. So this is the rule for finding the follow position for a star. And now, what is the next for the concatenation? For consider, you have a concatenation node. Concatenation node always have two child C1 and C2. Let us consider its first position is, let's say E comma F, and its last position is G comma H. And C2 nodes I comma J as first position, and let us take the last position as K comma L. Okay, this is the case. Now, how will you find the follow position? And so for this AND node, how to find the star follow position is like this. Every position in the last position of child 1 have all position in the first position of C2, which means G will be having all position in the first position of C2, that is I comma J. And H will also have all position in the first position of C2. So that is I comma J. So this is how we have to find the follow position for an OR node. Okay, and now I hope you have found how to find the follow position of a star node and how to find the follow position of a AND node. So like this. So every position in the last position of C1 node, all position from the first position of C2. So G will be having I comma J, H will be having I comma J. So I hope now you have understood all the rules. If you have any doubt, just once again you check the video, drag it back, and listen one more time so that you will be understanding it clearly. So now you understood all the rules. What we are going to do now, let's see an example how to convert a regular expression to a DFA. Let's take an example. I'm going to consider a regular expression as A or B clean closure star A, B, B. So this is my regular expression. This regular expression, now I have to convert to DFA, right? So let us go step by step. So what is the first step? First step, along with the regular expression, A, R, B, the whole star. And what if nothing is there? What is the meaning? It is concatenated with A, and A is concatenated with B, B is concatenated another B. Finally, as I told already, append the hash. So this is the first step. And what is the second step? Convert this regular expression to a parse tree or a syntax tree. So here, how to convert? First, you have to take the higher precedence operator. So always parentheses are the higher precedence. So I'm going to draw it first. So we have an OR node with two child, A and another one is B. Right? So this part is over. And the whole thing is having a clean closure, the star. So star, for this I have to apply a clean closure. Done. So this much is done. Now that is concatenated with what? A. So I'm going to concatenate this with A. And that is concatenated with another B. And that is concatenated with another B, right? So second B. And finally, we know that the last thing is concatenated with the hash. So now we have done with the converting a regular expression into parse tree or a syntax tree. So what is the next thing we have to do is I'm going to give a number to all these symbols, right? So this is 1, 2, that is the position. 3, 4, 5, 6. Same thing given the syntax tree as well. So 1 is the position. This position is 2, 3, 4, 5, 6. Then what we learn now, we are going to apply the functions. Nullable, first position, last position for every node. So according to this rule which we have discussed here, a leaf node, for the leaf node, we are going to find the nullable, first position, last position. For a leaf node with the position value I, the nullable is definitely false, right? So here we have a leaf node with position value. So for this, the nullable is false. So here also nullable is false. What is its first position? The position value itself. So 1 itself. Here the last position is also the position value itself. Here it is first position is 2, last position also same thing. So for all the leaf nodes, we are going to find the first position, last position. So for the leaf node with the position value I, the nullable is false. So here is also nullable false, and here also nullable is false. What is the first position? The position itself. The last position is also the position itself. So here again for B, first position is 4, last position also same. And for this B, the position value is 5, right? So that itself is the first position and the last position. For the hash, the first position is 6 and the last position is 6. So according to the rule here we discussed, the position I value itself is the first position and last position. So we done with the leaf nodes. Now we have to go to the other nodes. So what is the next node we have? Now we have an R node. So what is the rule for R node? If the R node's nullable value, first we let us say nullable. So for the child, we have to look at the child, right? So nullable of C1 is false, or nullable of C2 is also false. So false or false is false. So for R node, you have to do the R. So we have false, child 1 is false, child 2 is false. So if we apply R, false or false is false. So for this R node, the nullable is false. Now we have to find first position. What is the first position? First position of C1 union, first position of C2. So first position of C1 is 1, first position of C2 is 2. Similarly, what is last position of an R node? Last position of C1 union, last position of C2. So for last position is also same value. So we done with the R node. Now we have to do for the star node. What is star node rule? Already hope you remember here already. For a star node, here we have the rule. Star node nullable is by default true, and the first position is first position of the child 1, and the last position is last position of the child 1, because star node have only one child. So here nullable of the star node is true. First position is the child's first position. Last position is the child's last position. Okay. Now, again, now we have to do it for the concatenation node for this one. So, how will you find the nullable value? Nullable of child 1 and nullable of child 2. So, if you see here, for this AND node, nullable of the first child is true and the child 2 is false. So, you know for an R node, true and false is obviously false. So, nullable for this is false. How will you find the first position of this AND node? We have to check the child 1's first child 1. Child 1 nullable is true. So if the child 1 nullable is true, what do you have to do? First position of C1 union, first position of C2. That is what given here. The child 1 is true, then first position of child 1 union, first position of child 2. So here I have to take the union of that. So 1, 2, 3, which means first position of child 1 is 1, 2. First position of child 2 is 3 alone. So union means 1, 2, 3. Similarly, how will you find the last position? Last position, check the nullable. Nullable is false. False means what is the last position? False means the else part, right? Take the last position of C2 alone. So what is the last position of C2? That is 3. So 3. That is the last portion of this AND. Okay. So let us do for more time so that you will understand it clearly. Let us go for this AND node. What about this nullable? For this is the child 1 and this is the child 2. So child 1 is false. Here also nullable is false. So false and false is false. And now for first portion of this AND node, look at the child 1's nullable. It is false. So take the first position of C1 alone. So first position of child 1 is 1, 2, 3. What is last position of this AND node? Look at the second child. That is also nullable false. So for the last position, take the last position of child 2. So last position of child 2 is 4 alone. Right? So you have to be very clear about this rule. So if the child 2 is, what is the last portion? Child 2 have to check if it is nullable is true means take the union of both the last question, otherwise last question of child 2 alone. So we did it. Similarly, we have to do it for this AND node. For this AND node, this is the child 1 and this is child 2. So both are false. So false and false is false. So nullable is equal to false. What is this first position? Since the child 1 nullable is false, take the first position of child 1 alone. So it is 1, comma 2, comma 3. What is its last position? Since the child 2 nullable is false, take the last position of child 2 alone. Last position of child 2 is what? 5. That is what given here, 5, right? And then for this root node, what is its nullable value? Child 1 is also null, child 2 is also null. So false, right? So false and false is false. And what is its first position? Since the child 1 nullable is false, take the first position of child 1 alone. So it is 1, comma 2, comma 3. What is its last position? Since the child 2 nullable is false, take the last position of child 2 alone. So it is 6. So if you have any doubt, go through the rules which I have shown. So it will be very clear for you and it is very easy. So now we have found the 3 functions, first position, last position, and nullable, right? What is the next function you have to find? We have to find the follow position. So to find the follow position, already we have discussed the rules. If you have doubt, go a little bit back and listen to it, come back once again. So follow position can be found only for the start node and for the concatenation node. Okay. Now let us go one by one. So first we have to write all the positions. So in the syntax tree, how many positions we have? 6 positions. So let me write 1, 2, 3, 4, 5, 6. So for all the positions, we are going to find the positions. Follow position. Okay. So 1 represents the first leaf node, that is A. 2 represents the second leaf node. So I have to find the follow position of all this. So first, we have to consider only the nodes which have star or concurrent. So here we have a node with star. So how to find the follow position? What is the rule for a star node? Every position in the last position of child node have all the position in first position of the star node. So 1 will have 1, comma 2. 1 will have 1, comma 2. And 2 will also have 1, comma 2. Got it? And now let us go to the star node. If I have no other star node is there, and we have AND node here. So let us AND node. How will you find the AND node? For this AND node, these are the 2 childs. So how will you find for every position in the last position of child 1 have all position in the first position of child 2. So 1 have 3, 2 also have 3. So that is what again. Every position in the last position of child 1 have all position in first position of C2. So here we have only 3. So 1 will have 3, 2 will have 3. So we did it. We have written it here. Similarly, let us go to the next AND node. This is an AND node. This is a child for it. So how will you write? 3 will have 4. So 3 will have 4. So that is what we discussed, right? Every position in the, this one have all position from here. So you can see the middle one value. Similarly, for this AND node, who are the child 1, this one and this one. So 4 will have 5. So 4 will have 5. And then for this concatenation node, who are the 2 child? This 2 child. So 5 will have 6. So 5 will have 6. So that's all. So close the parenthesis. And for the 6th position, we don't have any other. So for no follow position. Okay, so this is how we have to find. I'll tell you one more little trick. How to find a follow position simply. So look at here. So here I have positioned all the inputs, right? A, B and all. So what is the follow position of 1? 1 means this A. Who will be following A? A can be followed by A itself because it's a clean closure, 0 or more number of times. So A can be repeated again, A followed by. So for A is one option. and followed by A, who will also another option B. B also follow A. So like when you get a language out of it, it can be A, or it can be A followed by B, right? So followed by 1 or that is 2. And other option is what? This A can also be followed by this A because 0 or more number of times. So if B is 0, it is not coming. Who will be following this A? This A, right? So this A. So this is third position. So that is why we say this A, the first A can be followed by A itself, that is the position value 1 itself, or B itself, or 3. So that's why we have written here 1, comma 2, comma 3. Same thing for, so we finished that, right? Similarly, we have to now say it for B. So B means position number 2. So for position 2, who will be following this B? Either it can be followed because 0 or more number of time, right? So B can be followed by A. So that is 1. And B can be followed by B itself. That is 2. So then B can be followed by 3. This A, if nothing is coming after this. So that's why here we have written 1, 2, 3. Now you see here, A, this A. That is 3. Position 3 is followed by only 4. After this A, only B is the only option. That's why for 3, the follow position is 4. For this B, who can be following this B? 5 itself, right? No other option. So that is why for 4, the follow is 5, followed position. Who is the next input string? And then this B, the position number 5 is followed by only 6. No other option. So that is why 5 is followed by 6. Who will be following 6? Nobody. So that is why we have here. So that is the meaning of follow position. Who is following a particular position value? Right? We have found all the now we have completed all the functions, nullable, first position, last position, and follow position. Now we are going to construct the DFA. So for that, what is the first step is? First step is take the root node. What is the root node here? Our root node is, this is the root node, right? This is the root node. For this root node, who is the first position? 1, 2, 3. So take the root node of the syntax tree or the parse tree and find the first position of it. So first position of the root node. So I have to say the first position of the root node is what? 1, 2, 3. So that we can name it as A, and that is the start state. So how will you, so you want to draw a DFA. So DFA have a starting state. Who will be the starting state means root node's first position. So first position of root node is 1, 2, 3. That 1, 2, 3, I have named it as A. So A means 1, 2, 3. 1, 2, 3 means A. So now we are going to find a transition. So for this A, when I give an input as small a, where are the place it can transit? That's what we are going to say. I'm going to say deterministic transition. That's what D-trans of A. When I give small a as input, where it will go. That's what I'm going to write here. So if you see here, A means, what does A means? A means it is 1, 2, 3. So in the position 1, 2, 3, who are all having input as A? So you see here, this is 1, 2 and 3. So in 1, 2, 3, who are all having input as A? 1 and 3 itself, because 2 is having input as B, right? So in this 1, 2, 3, 1 and 3 is having the input as A. So for that, find the follow position. So I'll say follow position of 1 union follow position of 3, because 1 and 3 is only, see, 1 and 3 is only having the input as A in the syntax tree. So what is follow position of 1? See the follow position table. 1's follow position is 1, 2, 3 and 3's follow position is 4. So take the union of it. So when I take the union, it is 1, 2, 3, 4. And this I am going to give a name as B. Right? So what is the meaning of it? For the state A, when I give input as A, it will go to state B. Right? B means 1, 2, 3, 4. Now, again, we have to write the D transition. I'm going to write D transition of A. When I give B as in, where it will go. So A means don't forget it is 1 comma 2 comma 3. So in 1 comma 2 comma 3, that is 1 comma 2 comma 3 is named as A, right? In 1 comma 2 comma 3, where it has the input as B here alone. 2 is alone having input as B. So you have to say follow position of 2 alone, because 2 alone is having the input as B. 1 and 3 is having input as A, right? So for this follow position of 2, follow position of 2 is equal to 1 comma 2 comma 3. So for 1 comma 2 comma 3 already we have given the name as A. So don't same name. See 1 comma 2 comma 3 already we have named it as A. So same name I am going to give for this. So this is over. Now we have to find the next D transition, that is deterministic transition of. Now we are going to have another state B, right? For this B, when I give A as an input, where does it go? So B means it is 1 comma 2 comma 3 comma 4. So look at here. For B, that is 1 comma 2 comma 3 comma 4, who are all having input as A? A means 1 and 3 alone. So 1 and 3 alone. Same thing as this. So I have for that alone, I have to find the follow question. Follow question means you already know what is followed by this input symbol, right? So it is follow question of 1 union follow position of 3, because in 1, 2, 3, 4, 1 and 3 is having input as A. This 2 and 4 is having input as B. So don't consider that. So you will be getting the same answer 1 comma 2 comma 3 comma 4, which is already named as B. That's it. Now again you have to do the D transition for the state, D transition of the state for input B. So for B in 1, 2, 3, 4 position, who is having B? 1, 2, 3, 4 position. 2 and 4 is having the input as B. So I have to say the follow position of 2 union follow position of 4, because 1, see 2 and 4 is only having the input as B. Oh, A, 1 and 3 is having A. So 1 and 3 we are not going to consider. So what is follow position of 2 and 4? 2 and 4 is follow position 1, 2, 3 and 5. So I'm going to say 1 comma 2 comma 3 comma 5, and this is new state which is not already there, so I'm going to give this name as C. So now let us go for the next deterministic transition for the next state C on input A. So remember, so if you see here, for C means C represents for your, again I'm writing it as 1, 2, 3 and 5. So in this 1, 2, 3, 5, see who is having input as C. So 1, 2, 3, 5, right? 1, 2, 3 and 5. Who is having the input? 1 and 3 itself. So 1 and 3, already we have for 1 and 3, we will be getting B. So I'm directly writing B, okay? Because you have to write the follow position of 1 union follow position of 3, which will be getting B. So in the next D transition of C, when you give B as input, C means you have to check the position 1, 2, 3 and 5. Why 1, 2, 3 and 5? See here, C represents 1, 2, 3 and 5. So in 1, 2, 3 and 5, check who are all having B as input. So 2 is having and 5 is also having B as input. See, 2 and 5 only having B as input. Remaining 1 and 3 is having input as A. So we are not going to consider. So we are going to consider 2 and 5. So here I have to say follow position of 2 union follow position of 5, because why 2 and 5? See, 2 and 5 is only having B as input. 1 and 3 is having A as input. So you consider only B as input, right? So what is follow position of 2 and 5? 2 is 1 comma 2 comma 3, 5 is 6. So which is 1 comma 2 comma 3 comma 6 when I take union. This is a new state which is already not there. So I am going to give the name as D. Now we go for the next. So until we get new question, we have to proceed it. So D transition of D on input A. So what is D in the sense? D means already we have now 1, 2, 3 and 6, right? So let me write D means 1, comma 2, comma 3, comma 6. So in 1, comma 2, comma 3, comma 6, who are all having input as a 1, 3, and 6. 6 is having what is input? Hash. So 1 and 3 alone. So 1 and 3 means already we know it is going to the stage B. So directly I'm going to write it as. So next is the transition of D state when I give B as an input 1, 2, 3, 6. You check 1, 2, 3, 6. 1 and 3 is input A and B is we have to find. So for D, we have to find the follow position is. So follow position. So for 1, B you have to check. For 1, 3 and 6, that is not having B. Only 2 is having B. Only 2 is having B. See, position 2 is having B. So we have to find the follow position of 2. What is follow position of 2? 1, comma 2, comma 3. What is 1, comma 2, comma 3? It is A. Right? Yes. Oh, so we have done. So now we don't have any other state called E or F, right? For all the new states, we gave the input A comma B. Why we gave only A comma B? Because in the regular expression, we have only two inputs, A and B. Hash is we dot we added to know the end of the regular expression. So for every state, we gave A comma B as input, C A comma B as input, A comma B as input, and we did it, right? So from this, we did it. So now we have to find a transition table. That is very easy. From this, we have to draw a transition table. How many states we had now? We had A state, B state, C, and D. What are the inputs we have? We have only two inputs, A and B. Now from this D transition, we have to fill this table. Okay, that is very easy. You see here, on state A, when I give A as an input, it is going to where B. So I'll say B. And then when state A, when I give B as input, it is going to A itself. So I'm going to write here A. Now you see input B, state B, when I give A as input is going to B. So write B. On state B, when I give small b as input, it is going to C. So write C. Similarly, C, in the state C, when I give A as input is going to B. In the C state, when I give B as input, it's going to the state D. Right. And similarly, in the D state, see, look at here, in the D state, when I give A as an input, it's going to B, and in the D state, when I give B as an input, it's going to A. So this is called transition diagram. From the transition diagram, you can now draw this, DFA. Deterministic finite automata. Either directly you can draw or you can first make the transition diagram and then you can draw. Deterministic finite automata is what is the start state? A. A is the start state. From start state, when I give A as the input, it's going to state B. That's what the given here, right? And then when for A state, when I give B as the input, it's going to A state itself. So here we have for B, it is going to same state. Then for B, when I give A as an input, it's going to B state itself. For a B state, when I give B as an input, it's going to C state. B is in here. And now, I hope you have understood it. So for B, when A as an input is going to B itself, for B it is going to C. And for C state, when A is an input, it's going to B. So from C it is going to B when I gave A as an input. And when I give for a C state, when B is an input, it's going to new state called B. And from this D, when I give A as an input, it's going to the state of B. It's going from here, it is going to B for an input of A. And for input of B, it is going to the state A for input of B. And this is the final state. So to denote the final state, draw a double circle. So this is the DFA, right? For finding a pattern, we for machine can efficiently use this DFA. So what are the language we can generate from this, or what are the strings we can generate for a state A when A is input? So one is ABB. So ABB is one string generated from this. What is the other thing? We can keep on giving A, then A itself. So I can say A, then B, B. So likewise, and then in the starting state itself, it can be B. So B any number of times, then followed by A, then A any number of times, then followed by B, B. Right? So then so likewise, from the starting state, you give any input and you can generate this kind of patterns which can be generated from this in DFA. So this is how we convert this regular expression to a deterministic finite automaton. Why it is deterministic? Because for an input A, it only go to B, it doesn't go anywhere else. For a B state, when I give A as the input, it goes to only B, no other confusion. So that's why we call it as deterministic finite automata. So this is how we convert a regular expression to a DFA. So DFA is easy for a machine to understand and execute it efficiently. Hope you have understand it. If you have any doubt, go through the video once again, and so that you will be very clear how to convert a regular expression to DFA. Thank you. God bless you.